So we have already learned the concept of traveling wave tube. Now I'll just say a glimpse of what we have learned. Traveling wave tube means it is a microwave amplifier. And why it is called as a traveling wave tube? As the electrons are moving, along with that our input signal which is to be amplified, it is also moving along with. So that is why we call it as traveling wave tube, and we can say that the amplification is happening, or the bunching process is happening, or the interaction with the electrons is happening throughout the device, because both the electrons as well as the signal is traveling together. And moving on to the next session, we have seen that the main differences between a klystron and a traveling wave tube is, the first one is the microwave circuit is a non-resonant in the case of TWTs. We do not use resonant circuits, instead we use the structures called as slow wave structures, whereas in the klystrons we use resonant cavities. And second one is the interaction of the electron beam and the RF signal is happening only in the resonant cavity in the case of klystron, whereas in the case of TWT, throughout the entire device the electron is going to be interacting with the input signal. Then the third one is the wave is propagating in a TWT because it is moving, whereas the wave in the klystron it is not. And in the last difference, in the case of a coupled cavity TWT, there is a coupling effect between the different cavities, whereas in the case of klystron, in the case of two cavity or multi-cavity klystron, the different cavity or the reentrant cavities, they are going to be working independently. And moving on to the structure, why do we go for a slow wave structure? There are different types of slow wave structure: helical line, folded back line, zigzag line, interdigital line, corrugated waveguide. Now why do we go for the slow wave structure? The concept is simple. We know that the electrons as well as the signal, the electrons as well as the signal to be modified or signal to be amplified, both are going to be traveling together. But the electron is having velocity of just a small value of c, that is approximately about 0.1 of c is the velocity of electron. And whereas the case of the signal is nothing but your EM signal, it is having a velocity which is equal to the velocity of light. So electron velocity is, we know that it is small letter v0, which is equal to root of 2ev0 by m, 2e capital V0 by m. What is this capital V0? It is nothing but the applied bias voltage or the beam voltage. So whatever it might be, the electrons which are coming out of the cathode, it is having just a very small velocity when compared to that of the RF signal. So since both of them are traveling together in the case of TWT, a proper interaction cannot take place. So what we have to do is, either we have to increase the velocity of electrons or we have to decrease the velocity of the waves or the input waves or your RF signal. So what we do is, we reduce the velocity of RF signal by the structures called as slow wave structure. As you can see, because of the structure, what happens? A signal which is traveling in a straight line, it will be having anyway a higher velocity when compared to the signal which is going to be traveling in these kind of structures. So the signal or the structures which is meant to reduce the velocity, of these waves or the input waves, we call them as the slow wave structure. And usually we use the helical line structure as well as the folded back structure. In our subject, we are going to be learning about the helical TWT. And moving on, when our signal is passing through a helix, what happens is, we know that the velocity is going to be reduced. Now the new velocity becomes Vp, that is a phase velocity, which is equal to Pc divided by pi d, where P is nothing but the helix pitch. So this distance is the helix pitch. And then C is nothing but the velocity of light in free space. D is nothing but the diameter of the helix, which is also equal to omega by beta. Very important, omega by beta, where omega is the angular frequency and beta is the propagation constant. And Vp is nothing but the new velocity, or we call it as the phase velocity. Now what happens is, as our input signal or RF signal, it is passing through the helix, a resultant electric field is going to be generated in the center. Now what the electrons are going to be doing is it is going to be interacting with the axial electric field or the resultant electric field generated. And now this new electric field is having this Vp or this lower velocity. And this is the concept behind the working. So here we have a heater supply and a tungsten filament which is going to be acting as the cathode. The cathode is being supplied by the regulated beam supply, and we have at the end a collector which is meant to collect the electrons after amplification, and to the collector we have the collector supply. The electrons are being attracted to the collector because of the positive voltage applied, and we are having a gain or modulation control voltage, and this is nothing but a slow wave structure which is in the form of a helical structure. And we have two attenuators which are nothing but we have two magnets which is placed, which are basically meant to focus the electron beams in order to prevent them from spreading. And we have an attenuator kept in this center which is meant to reduce the backward scattering or the backward waves. And the working is same as that of a reflex klystron or klystron principles. Here it is amplification. The electrons are going to be coming out from the cathode side. From the cathode side, the electrons are going to be pumped out. We have the RF input signal which is having a very higher velocity. It is being passed through the helical structure or the slow wave structure. So because of that, a resultant electric field is generated in the structure with a lower velocity, which is the phase velocity, which is given by small letter Vp. Now what happens is electrons, they are now passing through the slow wave structure. See, in the slow wave structure also your signal is being traveling, RF input is being traveling, so electron is also traveling. And during their travel, what happens, as we have seen earlier, we have the reference electron, the late electron and the early electron. The same process, the Applegate process, and is being happening. That is the electrons which are coming out early, which are late, as well as which are hitting the reference point or the 0 point. They move at different times, but they try to bunch together, and in the time of bunching they give their energy to the input signal, and likewise we get an amplified signal at the output. And this reduction in the center, it is because of the attenuator. It is mainly meant to reduce the backward scattering or the backward reflected waves, but it is going to be affecting the forward wave also, but it is going to be taken up in the further sections of amplification. And this is how the process continues. So we have the bunching process, the velocity modulation process, the bunching process happening throughout the entire device. That is because of the concept that electrons as well as the input signal is traveling together. Amplification process, we need to have a